Welcome to the second day of CCCI's two-year anniversary event. My name is Fan Dai. I am the director of the California-China Climate Institute. I would like to start my remarks actually with some housekeeping items. For those who you attended yesterday, you know the discussion for today will be around an hour and 30 minutes. We have simultaneous interpretation function available for the audience. At the bottom of your screen, you can select the global icon and select your preferred language, and you can mute the background voice. Throughout today's discussion, if you have any question you want to direct to the speakers or the panelists, please enter them into the Q&A box. We'll try to answer the question live as best as we can. And first, I would like to share quick readouts from this virtual Climate Week. We all know that President Xi Jinping, in his speech earlier today, addressed to the UN General Assembly, he made a new commitment that China will stop building coal power plants overseas, which was quite encouraging. However, according to the UN report card, which also the UN climate chief Patricia Espinosa mentioned, that we are actually on the wrong track. And if we keep going with the emissions that rising today, we will be around 16% rise by 2030 compared with the 2010 level. So which really called urgent action and more aggressive targets for other countries to stay on track for the Paris Agreement targets. So with those two quick updates, I wanted to introduce the two wonderful moderators for today. We have two panels, one on the transportation and one on energy sector. For the first panel on transportation, we're going to focus on green shipping and air quality improvements in California and China. This session will be moderated by Mary Nichols, who is the vice chair of the Institute and former chair of the California Air Resources Board. Mary has played a key role in California and the nation's progress toward healthy air. I don't think Mary needs further introduction, but Mary, I would like to hand it over to you to lead us through our first panel discussion on development and challenges in California and China on air quality and green shipping.
Thank you, Fan. This is a very timely topic, and certainly when we look at the role of goods movement and especially of shipping, this has been a leading indicator of how bad things are going in many ways for quite some time now. But at the moment, here in Southern California, where I live and work, we have ships that are parked offshore, off the harbors of LA Long Beach. At the moment, I believe there are 40 of them just waiting an opportunity to get into the harbor. And we are seeing, I think everyone has been hearing and reading about the supply chain issues that are affecting all sectors of our economy, from the slowdown in building of electric cars to various kinds of ordinary goods and things that people depend on in their daily lives. So shipping is a critical industry around the world. For those of us who live in port cities and along coasts, it's also a major, in some cases, the major source of pollutants that damage health, as well as of CO2 emissions. A lot has been done in this area over the years that we have worked on, both in California and in several cases in collaboration with Chinese ports as well. So it really is a global industry that has a history both of competition and in many instances of collaboration as well. But for now, what we see is that we have to move much faster, as Fan indicated, and much more dramatically in the direction of electrifying all types of port activities, all kinds of freight, and getting to zero carbon fuels everywhere they're in use. This obviously is not something that can be done overnight, but there is a lot that we can do in the short term through better information, taking advantage of digitization tools that we have, and ways that we could optimize the operations of the ports and the shipping industry to actually make meaningful reductions, estimated up to 20%, very quickly without any major new technology investments, but definitely calling for greater collaboration and sharing of data. But there are some additional benefits besides the carbon reduction potential through more efficient and faster movement of freight, because you not only can increase the environmental impacts, but you can also reduce the cost to businesses, both to the beneficial cargo owners and to the shippers, and make the terminals operate more efficiently as well. So there are big challenges here. I saw recently that as of right now, about 30% of all of the freight miles, so miles in which equipment is being transported and fuel is being burned, 30% of that is empty. There's nothing being transported. It's just moving the containers, empty containers, from one place to another. Now, all of these things are in flux at the moment as people change their patterns of work, their patterns of commuting, and consumption as well. So this is a very rich and lively area. It's also one of very critical economic importance, both in China and in the coastal parts of the US. Logistics is a key industry for us, even though most people are probably completely unaware of that fact. And that's part of the challenge, I think, in coming up with the kinds of solutions that are really going to be durable. So we have an expert panel to help guide us through both what's being done and what some of the current issues and opportunities are. And I would like to introduce them in order of speaking. So I'm going to start with Dr. Elaine Shen, who is the acting manager for the mobile source in indirect source rules team and the socioeconomic analysis unit. That's a handful there at South Coast Air Quality Management District. She's also the program supervisor for the International Clean Shipping Program at South Coast, spearheading a new initiative for multi-regional collaboration to reduce emissions associated with trans-Pacific goods movement, as well as other measures to reduce pollution from local port operations. Elaine received her PhD in economics from the Catholic University of Louvain in Belgium, and she's in the thick of it. So would you like to start us off, please, Dr. Shen?
Yeah, thank you so much for your kind introduction, Vice Chair Nichols. So I think before I dive into our agency's programs related to port and shipping emission reductions, I thought it might be helpful to first tell everybody who we are. So South Coast AQMB, or South Coast Air Quality Management District, is the largest local air pollution control agency in the United States. We have been fighting air pollution in the greater Los Angeles area since the 1940s. Our decades of work have cut regional pollution levels in health, mostly through stationary source regulations, but also by implementing many successful incentive programs to encourage the research, development, and deployment of cleaner mobile source technologies. Despite the progress, though, our region is unfortunately still the most polluted region in the United States. We still have a long way to go to attain our federal clean air standards for both PM2.5 and ground level ozone. In the meantime, pollution sources that we have very limited control over at the local level have become the more important forces driving our ozone episodes. And many of these pollution sources are tied to marine port operations. Our region is home to the largest container ports in the US, and we are the major gateway for ocean cargo imports from East and Southeast Asia, including China. At the same time, all the ships, hovercraft, heavy-duty drayage trucks, locomotives, and cargo handling equipment that are indispensable in facilitating global goods movement also produce significant levels of pollution and greenhouse gases. And as a regional air regulator in the US, we have limited authority over mobile sources, but we are pursuing all possible avenues to reduce port-related emissions. In order to accelerate clean technology deployment, our agency actually administers more than $200 million every year in incentive funding for clean trucks and equipment operating within our air basin. And we also work with major engine and equipment OEMs to accelerate the commercialization and market readiness of pollution abatement technologies. And earlier this year, our agency adopted our nation's first ever indirect source rule for warehouses in order to promote the use of and visits by near zero and zero emission trucks at these warehousing facilities, many of which are also the first stops after the containers leave the port complex. And with regards to ships, which is the focus of our discussion today, we are actively developing our PRIMER initiative. PRIMER stands for the Pacific Rim Initiative for Maritime Emission Reductions. So we envision PRIMER as a multi-regional framework where all partnering port regions would agree to coordinate our individual clean shipping programs in order to maximize the effectiveness of all the programs. And in this way, we can leverage all of our efforts and collectively incentivize cleaner ocean-going vessels on our shared trans-Pacific shipping routes. And California actually has long adopted low sulfur fuel and also shore power regulations that have significantly reduced shipping emissions close to our water or within our waters. However, what cannot be effectively addressed at the local and state level is really the emission of NOx when ships are transiting to and away from our local ports. And NOx plays a very key role in forming ozone and secondary particulate matter. And with long service life still remaining for the existing fleet of ocean-going vessels, we firmly believe that we need to seriously consider promoting retrofit solutions to not only reduce the existing fleet's carbon intensity, but to also lower the vessel's NOx emissions. We cannot simply sit here and wait for new and less polluting marine engines and ships to be built. For many port cities in China and in California, our environment and our regional economy are very much intertwined with port operations and the goods movement industries. This brings us unique strength, but it also means that the national emission standards and international environmental agreements may not be sufficient to fully address our unique environmental challenges, especially stemming from port operations. And this is why we believe a subnational, multi-regional approach is the best way for us to collaborate and tackle our environmental challenges head on. And with that, thank you again, Vice Chair Nichols, Director Dai, and everybody at the CCCI for inviting me here today. And I look forward to further dialogues and partnerships building for our common goals.
Thank you so much. And I really appreciate your sharing an overview of the South Coast Air Quality Management District's efforts in local air pollution prevention at our ports and improving air quality. It's already been a remarkable effort despite all the challenges that we continue to face. So our next panelist is Shaoli Mao. She is a marine senior researcher at the International Council on Clean Transportation. She leads and supports research on maritime policies that promote zero-emission vessels, regulating vessel emissions and efficiency, and she maintains the team's modeling tool as well. She has a regional focus on China in particular. Ms. Mao graduated from the University of Maryland with a master's in public policy and also holds dual bachelor's degrees in environmental science and economics from Xiamen University in China. So she's definitely an international, has an international perspective on these issues. Shaoli, if we could hear from you about what's going on with China in decarbonizing the shipping sector, as well as other sectors, other synergies in terms of improving air quality and climate change as well. That would be very helpful.
Great, thanks, Mary. First of all, can everybody hear me okay? Okay, great. Thanks for the question, and I'm truly honored to be here today. First, also a little background on what we do at my organization, the International Council on Clean Transportation, the ICCCT. We are a nonprofit independent research institute providing data-driven analysis to improve environmental and climate performance of the transportation sector. For the maritime sector, our main international policy venue is the International Maritime Organization, or the IMO, and our work covers both conventional criteria pollutants and greenhouse gases. We also work with individual countries and regions to not only live up to the IMO regulations, but also take a leadership role in advancing global policymaking at the IMO. China is obviously one of such countries emerging to show leadership potential. With the recent announcement of the country's carbon peaking and neutrality goal by 2060, the world is waiting to see how these targets lay out in each economic sector. Although little has revealed itself yet, we know that a detailed policy framework and timetable called the N+1 will soon be released. According to China's Special Envoy on Climate Change, Mr. Xie Zhenhua, although carbon peaking covers only CO2 from major energy consuming sectors, the neutrality goal will be more aggressive, covering all economic sectors and all greenhouse gases. There are 10 focused areas in this policy framework, including greening the electric grid and establishing a green transportation system. From these initial announcements, here are some of my interpretations on likely changes in the shipping sector for China. First of all, by 2030, I think the shipping sector will focus primarily on improving energy efficiency. This could lead to a national efficiency standard for the shipping sector, similar to IMO's EEDI and EEXI. At the same time, pilot projects on low carbon technologies and policy innovations will be promoted, including green ships, low carbon fuels, low emission ports, etc. As the country transitions to greener power grid, electrification will penetrate into the shipping sector, especially for smaller ships engaging in shorter transits like ferries and harbor crafts. Once peaking, I think the shipping sector will have to rely mostly on reducing the fuel carbon intensity to reach its neutralization goal. Depending on the country's strategic move to renewable energy resources and the allocation between different sectors, the low or zero carbon fuels for shipping could primarily be one type or a mixture of different types, like what we are now witnessing globally. Besides, China, which is one of the countries proposing something called a national action plan to be voluntarily submitted to IMO for other member states to reference, is working on its own submission, which could help IMO revise its greenhouse gas strategy in 2023. I think what this means for potential synergies with California is based on routes. Some of the world's busiest container trade routes are between China and California ports. A route is a great place to implement advanced policies and make a difference because it involves many stakeholders in trade, including cargo owners, ship operators, fuel suppliers, and infrastructure providers, namely the ports. A green shipping corridor between China and California, where green ships, low carbon fuels, and energy saving practices are promoted and incentivized on both ends, will not only build up good pilot projects in both countries, but drive down costs on those practices and bring down greenhouse gas emissions by not a trivial amount. Successful collaborations can be copied into other routes to reach an even larger scale impact, both nationally and globally.
Thank you. Before we turn to our third panelist, I should say to the audience that we are going to have some time for questions directed to the panelists. So if you have anything that you want to raise now, or as soon as you think of it during the final presentation, go ahead and put your question into the Q&A area so we can get things organized and proceed, because we don't have a lot of time for today's panels. Thank you so much. Okay, so our third and final panelist is David Woolley. And I should start off by saying that he is at Berkeley, at the Goldman School of Public Policy, where he's the executive director for environmental public policy. And he has over 30 years of experience with climate policy and Clean Air Act implementation. So we've crossed paths over the years in various different ways. But before he came to Berkeley, he directed the American Wind Energy Association's Northeast Policy Project. He's also served as counsel to the Clean Air Task Force and as vice president for domestic policy initiatives at the Energy Foundation in San Francisco. And he's the co-author of the West Group's Clean Air Act handbook. So he's a real Clean Air Act maven and expert. And I'd like to ask him to jump in and talk about what's going on from the regulatory perspective in California relating to shipping emissions and where you see any gaps in policy.
Great, thank you, Mary. I really appreciate being here to celebrate this CCCI's anniversary. I never miss a CCI webinar. The content is always so good. I followed China energy issues since my days at the Energy Foundation, and today really pleased to summarize some policy innovations underway here in China and to outline an idea for a trans-Pacific project on port and ship decarbonizations that I think would fit well into the Institute's mission and unique competencies. And it echoes some of the things that Shaoli just outlined. So I've been at the Goldman School for about 4 years, in which we undertook an effort to reduce air pollution hotspots near ports under the AB 617 environmental justice legislation. In that process, I learned a lot about ports and kind of enabling us to take a look at important opportunities to reduce both greenhouse gas emissions and conventional pollutants and air toxics. But first, a little sketch about what's happening here in California, largely under Mary's leadership at CARB and other state agencies. California is doing a lot to reduce the emissions from port and trade operations. Most notable is the pending drayage truck emission regulation. This builds on more than a decade of progressively tighter NOx, volatile organic compound, diesel particulate emission controls for trucks that enter and serve maritime ports. But the key thing is that CARB is now poised to phase in zero-emission truck requirements for trucks serving ports, with a full transition to zero-carbon drayage trucks by 2035. It's very ambitious and very timely because it addresses the co-emitted greenhouse gases and health damaging pollutants of diesel particulates and other pollutants. But there's a lot of other things occurring here in California. California pioneered the idea of shore power that allows ships to turn off their engines while in port. This had a big beneficial impact on air pollution exposure for port communities and people living near ports. The CARB is about to revise its longstanding hovercraft rule, which will reduce emissions of conventional pollutants from tugboats and other vessels serving ports. And we're hoping that it may even be strengthened to include some zero carbon engine technology phase in for those vessels. California pioneered the hydrogen highway idea, rapidly developing infrastructure for renewable hydrogen supply chains that could drive greenhouse gas emissions in road transport, but ultimately other industries and manufacturing that will have a need for renewable hydrogen, including fuel potentially for ships. I mentioned AB 617. This was a really important initiative to directly take on air pollution hotspots near ports and other large sources. And here again, the pollution that we're dealing with is often co-emitted with greenhouse gas emissions. So there's a double benefit from those air pollution hotspot control plans. California is on the leader in the low carbon fuel standard regulatory area. This is a market-based mechanism to lower carbon intensity of transportation fuels. This has a big benefit for port communities and driving a whole lot of innovation around fuel. Other states are beginning to copy this well-established legislation. The state has a renewable portfolio standard which drives greenhouse gas reductions down directly and indirectly for power that serves for electric power supplies for ports. Elaine mentioned the low sulfur fuel requirements and incentives is another important innovation here in California, and not to mention a whole range of funding for R&D and pilots on zero carbon locomotives, trucks, port gantry trains, and many other things that California agencies are undertaking now and have over the past decade at least. But there's still a lot more to do here, and this is partly a function of the opportunities continuously arising as a function of evolving technology, markets, and politics. I'd like to focus the rest of my time on ocean-going ships and some steps to decarbonize those. So why ships? Shipping emits over 1 billion tons of carbon a year, making it the 6th largest emitter in the world after China, US, India, Russia, and Japan. And it's projected to go 50% higher by 2050. The ships are large sources by themselves, but even larger when considered in the context of port and cargo drayage operations. Imagine the pollution from I think Mary, it's almost 70 ships now idling off the coast of California. And of course the emissions en route to California and back to home ports in the Pacific Rim. Ports worldwide are often co-located with other large pollution sources, particularly refineries and chemical plants. There are examples of that in the Bay Area and near the ports in the LA basin. Ships burn refinery products, that gooey, highly toxic thing called bunker fuel, along with lots of diesel for ancillary engines and attendant tugboats. Refineries and chemical plants use large amounts of fossil-based hydrogen, so there's a synergy here that I'll get to in a moment. Ships are hard to decarbonize, not just due to the quantity and energy intensity of the fuel needed, but because of limited jurisdiction over ships by local, state, and national governments. But it doesn't have to be that way. There are two key steps that California and China could take to decarbonize not only shipping, but other industries which are often located nearby: cement, steel, fertilizer production, and liquid fuel refinery. And so the two concepts here that I'd like to present are: one, develop renewable hydrogen hubs. This may involve methanol, renewable hydrogen directly, or ammonia. But develop these hubs near ports to supply ships and nearby manufacturing, perhaps coupled with carbon sequestration industries and industries that use CO2 as a feedstock, carbon dioxide as a feedstock. Secondly, develop a market for alternative ship fuels via a zero carbon trade corridor, like Shaoli described, between Maritime and California and China. So why a Pan-Pacific cooperative trade corridor? It's because we need zero carbon fueling infrastructure on both sides of the Pacific. Ships can't use one fuel coming to California and another to return to China. You need a partner on both sides. The timing is really ripe for this. Cargo owners like Amazon, Walmart have a mandate to clean up their supply chains. The IMO is under pressure to cut shipping emissions. Proposals are circulating for a CO2 tax or charge on CO2 emitted by vessels. Contracts are being written for the supply of carbon-free fuels in shipping. Ship owners like Maersk are beginning to contract for new ships that do not use fossil fuel. Subnational governments have a large leadership opportunity here, especially when national governments are distracted by other disputes. There's a lot more going on. I'm over time, so I'm going to skip a few of these other signals that are out there. But just to close by noting the important work that South Coast Air Quality Management District is doing with their Pacific Rim Initiative. And my suggestion here is that we continue and build on that effort while taking a bold step towards zero carbon shipping in ports. This will create new markets for port services. It'll create multiple ways to utilize feedstocks for zero carbon fuels by nearby industries. Both countries need this to get off imported fuel, to improve public health in port communities. And my vision is that CCCI can be a catalyst to bring the stakeholders together from both countries together to launch these kinds of new markets. This is definitely long range. It'll need multi-year funding, but I think that this kind of a project would appeal to a wide range of philanthropic, private, and market participants. So thanks again for having me, and once again, congratulations to the Institute and its founders for this anniversary celebration.
Thanks, David, and thanks for those very specific and ambitious ideas that you've laid out here. I'd like to follow up a little bit with our other panelists, starting with the idea of what some have called a zero emission or a decarbonized shipping corridor. I think Shaoli referred to it as a route, but I kind of like the vision of this zero emission corridor with the ships chugging back and forth. And I'm wondering what you think the actual feasibility in any kind of a reasonable time frame might be. That may sound like it's too political a question, but I know you're familiar with the discussions that are going on now at the international level. And maybe you could give us a response to the idea that since both countries at the national level do need to bring down emissions, and shipping, as we've just heard, is a major sector and source of greenhouse gas, as well as of local pollutants that create real issues of concern for people who live near the ports. Do you see that this is an area where there could be some real opportunity to create collaboration, even when at the level of the United Nations, it may be too difficult?
Yeah, sure. I'll start. I might be more positioned to answer the feasibility question rather than the time frame question. We have done a feasibility study of such a corridor between a Chinese port, which is Shenzhen, and the San Pedro Bay ports in general. So the study is about the feasibility of replacing fossil fuel with just liquid hydrogen along for just the container route between these two ports. Our results are actually very promising. We found that 43% of existing voyages can be replaced with liquid hydrogen without any modification. Plus, by replacing up to 5% cargo space, that's about like 300 containers, standard containers, that amount of space, or by calling one more refueling port, nearly all voyages can be powered by liquid hydrogen. Well, we did this because we know that people are really afraid of the range limitations of using hydrogen. So we sort of want to see, for this like extremely long range deep sea shipping, how feasible, like only on a technical basis, how feasible this would look like. And it's quite promising, actually. We also analyzed, did some follow-up analysis on where these additional refueling ports might be located and how much liquid hydrogen refueling demand will be distributed along different ports along this route. And actually about 1/3 of the total demand will be placed at the San Pedro Bay area. And another like nearly 30% will be located in the general Northeast Asia, including China area. So I would say on the technical analysis standpoint, it's already quite promising and quite feasible.
And this may be an ignorant question, but I'll ask it anyway. When you're talking about the hydrogen, liquid hydrogen, how is it actually going to be utilized in the ship?
It's going to be used in the fuel cell.
It will be a fuel cell. Okay, great. Thanks. And for South Coast, for Elaine, what do you think, given that the ports of LA Long Beach have already seen some investment in hydrogen? There, I know, is at least one large effort going on that Toyota started to demonstrate the use of a container transport truck on the harbor, in the harbor, that they brought in hydrogen for. And I've heard that the port is quite interested in the potential for more hydrogen related projects. How do you see that actually being able to play out?
So thank you again, Mary. So if the question is whether hydrogen can be readily applicable in the maritime sector, and I think we will agree with Shaoli that in the long run, it would be really ideal if we have zero emission technologies being available for the transoceanic routes. And I think our concern is really that regarding the current technologies, hydrogen fuel cell are mostly applicable for shorter routes, or regional routes, or even local routes. And so going back to our primary initiative, we are really looking at like focusing on the in-service vessels and how we can make them cleaner, because the majority of them, they're still anywhere from tier 0 to tier 2 and not even tier 3 yet. So the engine tiers are with regards to the NOx emission rates. And so if in the short time, within the very short time frame, or for our near-term emission reduction benefits, we do not believe that it would be feasible to retrofit these ships as yet to the alternative fuels. And so right now we're looking at retrofit technologies that would be able to be compatible with the current diesel combustion engines in order to reduce emissions already for the ships that are already deployed into services. And so Yeah, I think it would be a very interesting idea to build up the hydrogen filling infrastructure little by little at our local ports and also around the major international hubs around the Pacific Rim. And we want to just emphasize the point that we are looking at two kinds of ship fleets here, or ship population. So the first one is really the in-service fleets. What are we going to do with them in the next 20 to 30 years when they are still in service? And is it feasible for them to adopt any of those newer technologies, or it's a limited range of retrofit solutions that we're looking at? And so the second point is that we totally agree that the international trade route or trade corridor concept is really encouraging. And we also wanted to bring up an idea that maybe we are thinking does not have to be restricted to routes or corridors. So if I may, I would like to share one visual with everybody. Yep. So on this visual here, you can see that we actually analyze the frequent callers at our local ports. So the frequent callers are those ships that call San Pedro Bay ports or ports of LA and Long Beach at least 5 times in a calendar year. And they also call at least one of the Pacific Rim ports at least 5 times within the same calendar year. And so we know that there are thousands of ships out there, thousands of ocean-going vessels. But if we're looking at only the frequent callers, we're only looking at a set of about 100 to 200 container ships going frequently between all those different Pacific Rim ports. 1 year, or maybe within a quarter, they may not be deployed to always the same routes, but then they are always visiting this same set of Pacific Rim ports. And therefore, if we can work together with all these ports, we don't have to restrict our thinking to just the routes, because actually they might be hopping from one route to the other, but always visiting, for example, Shanghai, Ningbo, Zhoushan, down to Shenzhen, Guangzhou, and Hong Kong. And then they come to our ports as well, not just in Southern California and also in Northern California, in Oakland. And so if we can share some of those costs to incentivize these ships to adopt cleaner technology, it's a win-win situation for all of us.
Thanks, Elaine. I think you've presented an interesting sort of an option or variant on David's idea, which would be sort of a clean fleet, a dedicated clean fleet, perhaps, as opposed to just a corridor. I'm going to have to bring this section to a close. I'm already over time and eating into the time of the next panel. So I just want to quickly thank you very much for bringing all of these ideas and background to this discussion. It's another example, I think, of how the CCCI can really play a useful role here in moving discussions forward that otherwise might have a hard time taking place. So thank you. And I'll turn the program back to Fan Dai.
Thank you so much, Mary, and all the panelists. It's been a really interesting discussion, and I know in the April joint statement by the U.S. and China earlier this year, it was identifying actually international maritime activities and low carbon transportation as one of the key areas for potential collaboration between the two countries. So really glad to see that we're getting the conversation started here. Moving on to the second panel today, it's focused on energy, and we are going to have Bob Weissmiller, who is currently a research affiliate with the California China Climate Institute, who, as a lot of you know Bob very well, the former chair of the California Energy Commission and one of the state's leading voices on energy. I'm going to hand it over to Bob to start us off this panel discussion on common electrification challenges in California and China on battery safety and second life usage of battery. Bob, over to you.
Oh, thank you very much, Fawn. This is very interesting topic now. As some of you know, when I was chair of the Energy Commission, I was actually designated as the scientist engineer. And that means I've always had a lot of interest in the technology innovation. And one of the really nice parts of the Brown administration, and probably more starting out closer to 205 with Schwarzenegger, was there's been a lot of technological innovation, which has given us a lot of new options. Obviously, solar photovoltaic costs have really come down. Wind costs have come down dramatically. LED lighting costs have come down dramatically. And obviously, part of what's really given us great opportunities now is battery cost, and that's driving zero emission vehicles. So batteries are really becoming a dominant part of the clean technology industry at this point. And just looking over the past decade, again, looking primarily at lithium ion batteries, costs have come down about 90%. And that means that the opportunities for using batteries have gone up substantially. And a lot of that, frankly, has been driven by the transportation sector. In China, there's about, over the beginning of the year, there was a little under 5 million new energy vehicles. Now, that could be battery, it could be hybrid, it could be fuel cell vehicles, but we would suspect most were batteries. And at the same time, the US or Europe was the next largest market, and then the US had about 1.8 million. Again, because zero emission vehicles are at least moving in that same broad category, and a little under half of that are in California. And so again, what's really enabling this transformation now, and a key part of going forward, has been battery technology. And in fact, as we all heard, the governor's goal is to really end internal combustion sales starting in 2035. And we're talking, as I think has been clear from the last conversation, not only about automobiles, but obviously trucking, taxis, buses. I mean, the whole transportation fleet needs to be converted to zero emission. And that may be batteries, frankly, it may be fuel cells, but the batteries are a key part of that. And as batteries have become lower cost, they've also moved into other parts of the system. For example, the grid. Now in California, we're using batteries a lot to stabilize the grid in an era when we have increasing amounts of intermittent wind and solar technology. And as we've looked at some issues on grid reliability, one of the things California has been really doing is scaling up grid batteries. In fact, an interesting connection to what Mary was talking about was back in July, talking to people in the administration. They were trying to figure out how to get batteries off of those ships in LA Harbor, actually to get them installed in California. So everything ties together in some fashion. And along with the grid, there's been a lot of battery rollout into buildings now. There's been a lot of focus on microgrids, and while there's a lot of definitions, I think all of them are based somewhere around batteries. And certainly even the Title 24, the new Energy Commission building standards, will require a solar battery combination in larger buildings. So again, batteries are at this point sort of everywhere. And the next thing is, as batteries have been around about 10 years in some of our automobiles, one of the questions is, what's their lifetime limits and what do we do next? So there's been a lot of vision about basically going to second use life for batteries. Where the Energy Commission, when I was there, funded some UC San Diego activity to again take batteries that have been used in cars that were drawn down below a useful level for that application, starting to use them in buildings. There's also now requirements, certainly in China and also California, for recycling batteries. So again, there's a whole bunch of reasons why, thinking about it, if you could take the automobile batteries and use those for second life as opposed to dealing with recycling, then presumably you're reducing the cost again. And the more you can reduce battery cost, then the more you can scale up the applications. Now, as we move forward towards cheaper batteries with higher energy density, safety issues are emerging. I mean, again, I'm not saying they're huge. I think Tesla always compares them to fires in internal combustion vehicles. But, AES had a power plant in Arizona, which had a major fire. Tesla in Australia had a major fire. Certainly Chevy Bolt, we've all seen the headlines on that. Hopefully they now have a solution. And I would point out that California had hit the record of the largest grid-sized battery at the old Moss Landing facility, or Vistras. And that's 300 megawatts with 1,200 megawatt hours, and they've actually expanded another 100 megawatts. And that phase one again it now has had problems. So basically, I think as a scientist engineer, I always look about how do you solve the problems as opposed to somehow viewing those as insurmountable. And certainly, we all know there's a huge future potential for batteries. So the question for everyone is how to deal with these issues now, as opposed to say 10 years from now, when we're much more dependent on batteries. So again, looking forward for a great conversation on these issues. And I would start out with one of the things that's been very interesting is just given the fragment of authority in the US on some of these questions, like is this an Energy Commission role as part of its siting? Is it an Air Board role? Is it, all the various federal aid entities? The Chinese are starting to take a very proactive approach on dealing with some of the battery safety issues. And they've actually had, obviously, battery issues too. So we're very honored tonight to have one of the Chinese experts to discuss how they're approaching this. So again, I've got 3 participants. We're going to start out with Ouyang Mingyia, who is a member of the Chinese Academy of Sciences, director of the State Key Laboratory of Automobile Safety and Energy, professor at the Department of Automotive Engineering at Tsinghua University in China. And from 2007, he has been the chief scientist of the Chinese major national R&D program on new energy vehicles. So again, thank you very much for your participation.
Thank you. Yeah, concerning the battery safety, it's in China, we have investigated this problem for more than 10 years. In my university, I have established the battery safety laboratory. So we have a comprehensive research on the battery safety. We are focused on the NCM, the high energy density battery safety. Now, we think we have fully understand the mechanism of the thermal runaway inside the Nissan batteries. So we have the solutions for the Nissan battery safety. So we think in the 3 or 5 years, we can solve these problems. At the moment in China, the safety accident for electric vehicle, the percentage is about maybe 0.01% or something like that. So this is the equivalent of traditional internal combustion engine vehicles. So this is low levels. The problem is for the energy storage stations at the moment in China, also in all of the world. So because the batteries storage stations normally have a large number of batteries, normally several, maybe 2,200 million watt hour, or something like that. So this means it's a very, very much large the capacity than the electric vehicles. So in recent years in China, we have some accidents from the battery storage stations. So that's a problem at the moment. So normally we have two types of lithium batteries, AFP and NCM. And in the electric vehicle, normally the NCM is more dangerous than the AFP. But for the battery storage stations, the AFP also dangerous. So that's why in China we have several policies to manage these issues. For example, we have recently the government have issued regulations this means we cannot use the recycling battery for energy storage stations. Yeah. Originally, normally we can second use the AFP batteries for storage stations, but now we cannot use that. This is a new policy. The main reason is for the safety. So at the same time, for the electric vehicle, more and more AFP batteries used in the vehicles. Also for safeties and also, of course, for cost reductions. So several reasons. So that is the basic current situation in China.
Thank you. Thank you. That was very helpful. And I think let's go on to the next piece. But as I said, it's very interesting that China has been in the position to really start actively dealing with it. Again, I don't think there's anyone in the U.S. who's at this point saying, don't recycle batteries into microgrids. Don't do second life because of safety issues. And something we at least think about. But let's get more perspective from our U.S. participants. So next would be Elisa Kendall. She's the professor of the Department of Civil and Environmental Engineering and the chair of the Energy Graduate Group at UC Davis. She has research applied and advances the methods of industrial ecology to the understanding and to reduce the environmental effects of transport, civil infrastructure, energy, and agricultural systems. So please welcome aboard and looking for your contribution on this interesting issue.
Thanks so much, Bob. And it's a pleasure to follow Professor Mingao's context from China, which is really exciting to hear. So I'm going to start by just talking about the main challenges for battery reuse and recycling broadly as countries accelerate adoption of electric vehicles. And the biggest challenge is timing. So as we adopt these vehicles, we have sort of a slow start, and then we see something like an exponential growth for a little while. And on the reverse side, as these batteries come out of these vehicles and are retired, we see a trickle of batteries essentially entering the end-of-life industrial ecosystem. And because of that, we just don't have the economies of scale to really have a market-driven or profit-driven recycling and reuse industries. And so we have a chicken and egg problem because until we get that big flow of batteries out there, we're not going to necessarily have the capacity to handle them. And this seems like a really good place for policy to potentially intervene and make sure that we have the capacity to safely and sustainably manage these retired batteries. So that gets us to the policy point. And I think one thing to point out is the US doesn't have one. We do not have a policy for battery reuse and recycling. I will say California has an advisory board put together right now that is supposed to provide some guidance to the legislature, but we really don't have any policy in place. In fact, what we have is simply a few regulations that affect end-of-life EV batteries. So they are designated as hazardous waste, for example, and that means they can't be put into a conventional landfill, but doesn't mean that they have to be recycled and reused. And this designation also is important because it actually significantly increases the cost of transporting batteries. And battery transport has been estimated to comprise something like half or more of the cost of recycling, for example. So when you look at the value proposition for recycling, you can see that these costs, which may seem trivial at first, like transport, really aren't in terms of relying on a sort of purely market-driven end-of-life industry here in the US. I'd like to quickly contrast that to what we see in China and in Europe, where there are much more holistic policies in place that think not just about batteries at end of life, but linking that end of life to battery production so that you integrate the value chain. And that's important because if you're going to recycle batteries, for example, you need an industry that's going to use the secondary material coming out of that recycling system to produce new batteries or produce other products that rely on the same materials as batteries. There's some other issues I should have commented on as well for these industries. For example, as we drive out some of the high cost materials like cobalt, and we also drive down the value of recycling to companies. And I'm emphasizing this because it does mean that we probably need some really thoughtful policy in place to ensure that we actually get recycling and reuse of batteries in the US in order to safely manage these batteries at end of life. And just to actually think about what the landscape really looks like in terms of recycling reuse in the US versus other places. Some research that my group did shows that will probably will comprise about 20% of global EV battery demand through 2040 here in the US. But we comprise literally just a few percent of global battery recycling capacity. From China, we see a really different picture. So China comprises just under 30% of global electric vehicle demand through 2040, or that's our projection, but they make up 65% of global recycling capacity. And so we are kind of uniquely positioned to be demanding lots of these batteries and putting them into use without a plan for what happens at end of life. And we see that Europe just put out a few months ago, their sort of revision to their battery directive, this new battery regulation, which may have some challenges, but they really have thought about linking, that holistic picture of linking recycling, reuse, and of course the industries around that for essentially having a market for the secondary materials even. So if there's one takeaway, it's clear that the US and California as well, but the US really needs to think about having a policy like the rest of the world that is that are adopting EVs at rapid pace, and that we need to maybe learn from what's happening in China and elsewhere to think about what policies might be powerful. And just to link this to sort of the ultimate goal, we are pushing for electric vehicles because we think they can really deliver on reducing greenhouse gas emissions from the transport sector, and they have this amazing co-benefit of reducing air quality pollutants as well, especially in areas with poor air quality, like in California and a lot of urban areas. And so we need to make sure we're actually achieving that. And one of the key things that has always been true about electric vehicles is we need to think about them from a life cycle perspective, and it always matters what grid you plug them into. And I think Bob did a really nice job of sort of pointing out that the landscape for batteries isn't just about electric vehicles, it's about our electricity grid. And in California, we're doing a great job of decarbonizing, but to do that, we need ways to integrate ever increasing proportions of intermittent renewables, and batteries are clearly going to play a key role. So whether it's in the form of reused batteries, which we have already heard may or may not really be what happens out there, partly because of the really rapid reductions in new battery prices, not just safety concerns, we do need to think about sort of batteries in this holistic sense. And when we think about solutions for end-of-life batteries from electric vehicles, we should keep in mind that we have this demand for batteries on the grid, and whether it's about creating infrastructure that can manage all these batteries at end of life safely and sustainably, or whether we want to integrate them and see reuse of electric vehicle batteries on our grid. I think having a more complete picture of what the landscape looks like will lead to better policy development in the future as well.
Yeah, thank you very much for helping us frame the issues. Let's go to our last participant tonight, and then we can hopefully have some back and forth among all of us. So Anna Stefanopoulou is director of the Energy Institute and the William Clay Ford Professor of Manufacturing at the University of Michigan. She's been on the faculty of the Department of Mechanical Engineering since 2000. She has numerous publications on estimation and of internal combustion engines and electrochemical processes such as fuel cells and batteries. Please go ahead.
Thank you very much, and I'm really happy to be here following Dr. Wu Yang and Alyssa Kendall. So I actually, since I'm the last one, I figured, well, you know, maybe I can share some slides so I can focus a little bit my quick chat here that I want to, and the issues I want to raise. So let me share really quickly my slides. I hope you can see. So I'm from University of Michigan, like Bob said, and as you can see, here in actually Indiana, Illinois, Michigan, and Ohio, as this map shows, we're actually manufacturing a lot of the vehicles and parts that actually will go away, hopefully, well, because of electric vehicles and because we want to stay on the track for battery electric vehicles and for the climate change. And so we have obviously a lot of lion's share, the huge investment in manufacturing here in the automotive sector. I want to highlight here, let's see if I can, staggering numbers that we have to produce to scale up. Like we have, if we put the goals for 1.75 Celsius scenario increase, so we actually in the US 50%, we have to reach 50% of sales in light duty vehicles. That is 2,000 prismatic cells per minute, producing actually in batteries. So that's a very large issue, and the issue here, like Bob said, is that at the same time we're trying to, and Alyssa, that we're trying to scale up both in the automotive sector and also at the grid. So can we learn from field data? The big issue here is to learn from the field data, to actually receive continuously data so that we can actually assess, estimate the state of health of the battery and allow us to do health prognostics so that we can hopefully create second life opportunities. We can understand the metrics for which this can be actually profitable, so that we can, and of course safe, so that it can stay, the battery can stay long in the grid and help, or it can support charging infrastructure for rural areas, or it can actually support lighting and other low power technologies. So learning from the field is extremely hard. I really wanted to share this graph. In a sense, trying to look at data, looking for wrinkles in the data that can actually show us, tell us more about degradation, about safety, and about allow us to prognose and predict if actually this battery that this data came from would be actually safe and meaningful to take apart and reset, re-engineer in a different module. In the laboratory, just to give you an idea, we can actually take batteries and charge them, discharge them, but the battery electric vehicle operates here. So this is an A, fresh battery, and a B, old battery. And you can see that for battery electric vehicles, if you were receiving data from this early, from this high state of charge, you would not actually have even a sense that your battery is aged. Only super users are actually really seeing the effect and learn quickly about, well, they age their batteries, but at the same time, they can actually see the degradation and know the degradation. Whereas it's hidden for a lot of us, only when occasionally we will want to drive in such a high depth of discharge, we would know about. There are other signals, however, that can actually inform us about a state of health. And I think it is very important to explore a lot of things, including a lot of the signals that we use in data analytics, but also to merge with physically meaningful features. Professor Wu Yang mentioned about really understanding thermal runaway, and his laboratory is pioneer on that. So can we actually build from the data, feed to physics, and use the physics to predict forward? In the area of safety, it is extremely important to realize that batteries are extremely powerful. This is the range of a vehicle, and this is the fire heat release that you would have from an EV and a gasoline. So for the same range, you can see that the heat release actually capacity is much higher. And it is important to not only design and engineer large energy storage systems to contain thermal runaways, but also to actually be safe and assess risks and send warnings to when they're actually failing. An example here, and I guess a big push, it would be important for using multi-sensors and current, voltage, temperature, pressure, gas, and involving more data and more physics that we can be informed from the physics so we understand the state of health of the battery. Another area that is also important in the kind of a middle life stage of a battery is the fact that even if it goes to recycling, it will have to be transported. It will have to be actually stored in an area. And there are going to be a lot of them that they're actually, it's not easy to take data from them. Here is a picture with a lot of batteries inside a bin in a recycling, in a facility that will transport and sort batteries for recycling. In these bins, if a fire starts from one battery, then you actually need a plethora of sensors in order to actually alert the personnel and have the suppression systems. Suppression is not easy from batteries because they have the internal oxygen storage. So actually covering them with, depleting them from oxygen from the atmosphere is not helping, or at least it helps to cool them down, but they can actually reignite. So it is important to understand and access, again, data and include a lot of sensors and engineer the systems, not on the pack, but in the container, and also a lot of awareness in the public and in our first and second responders. We don't have time to figure out how to say everything. I think we are learning as we go. And I think it is so important to share activities between China, Europe, and the US and across the globe about events that are happening and share data more and more about degradation. So thank you very much.
Thank you. Thank you very much. I would like to have a dialogue among folks. So I think, okay. So following up on the dialogue, I think I just want to start with a couple of the obvious points. One is that California has about a little under half of the electric vehicles in the US. And California has been certainly leading the progression of electric vehicles. So in terms of worrying about electric vehicles and batteries, we're there. And similarly, if you were to look at in the US, what's the percentage of, say, batteries on the grid in California versus elsewhere? Again, we dominate that. Or similarly, if you were to say, what about in buildings or people's houses? Well, again, California really dominates that market too. So having said that we really dominate battery usage, we don't really manufacture. I guess we have some Panasonic coming in from Nevada, but certainly our batteries generally are coming in from China or Korea or perhaps Japan. So going forward, as we start worrying about recycling and safety, we're right there. And so part of the challenge, I think, is how do we have a deep dialogue with China on these issues and learn from your expertise on planning, safety, and also recycling. again, I think the natural course of events would be to see a lot of our used batteries moving into some grid or microgrid situation. And as you said, that could certainly have some safety issues. So I think California has to be ground zero on dealing with these issues. So I'd like to get each of your reactions to what California should do going forward.
Well, maybe I can offer some ideas here. First, I think that California does have to be a leader in the US. And I think like so many times, we might make the first move and see a lot of the ideas that come out of here adopted elsewhere in the US. And I think that's important because we do need, I think a state on its own probably can't implement what's needed at the policy level here. So first of all, I think that we do need some of the basic standards that might be out there that would help with the kind of information and that needs to be out there for users and first responders. And I think Anna did a really nice job of laying out what's sort of, we talk about state of health, but I love the idea of a state of safety, and we really need to have that as a critical component of policy. I think we also need to realistically think about what infrastructure is needed to safely handle these batteries at end of life. If transport presents a great risk at end of life for transporting these batteries long distance for recycling, what is the right way to set up our recycling infrastructure? And that's crucial. The idea that we should ship these batteries long distances to be recycled if they're not, especially when they're at their end of life and have greater safety concerns, seems really problematic. So I think it's really important for California to start probing those particular issues and think about the kind of infrastructure that they think is required, and then think about policies that will help that infrastructure develop.
Great. Anna, you want to go next, or Professor?
Sure. I would like to bring up also training. It is so important to batteries are going to touch the lives of course, the users. But we will need technicians. We will need the maintenance. Takes time and effort, and it's actually much more time-consuming to diagnose a fault. Even with the help of the OEM or the manufacturer. We have actually EPA just issued a report recently about a lot of the problems that happened in waste management associated with batteries, about people that they just put their vacuum or drill pack battery in the vacuum cleaner or drill pack in the garbage and gets crashed. So we really need to, I think California can be pioneer also in the area of education for technicians and engineers, and of course touching on the manufacturing, but also on the servicing.
Yeah, Professor, what would you say is the 3 main lessons from China for California on batteries?
In China, we have several technology approach for the battery safety and the recycling process. For example, is exception of the manufacture of the batteries, and also the monitoring of the whole process of battery using. So this is very important. So now in China, we have a national electric vehicle monitoring system platform. And also in every vehicle, we have the intelligent, the AI using the battery management systems for the safety diagnosis. So that's the technology approach for vehicles, also for the infrastructure. For example, for the charging system, we also have the safety monitoring system for that. And this means we are now development of the life cycle monitoring data acquisition system for battery use. even for the recycling process, we also need the monetary data. So this data is very important. We need all the data for the state of the safety of battery, also state of the health of the battery. So that's very important for safety, also for recycling. In spite of that, we also have the approach to reduce the safety accident for the battery in that grid. Now, right. Of course, we have a lot of battery use in the grid, now increasing very quickly. But we think in the future, the electric vehicle will increasing very quickly in China. In this year, we have 6 million EV in China. We think in 2025, we're more than 20 million electric vehicle. In 2030, we maybe have the 100 million electric vehicle in China. So this means actually the electric vehicle can be integrated to the grid. So this means a vehicle to grid, V2G, will be the main means of the energy storage by grid, by batteries. So now we're in China now also developing this kind of technology to establishment of different level of the battery V2G infrastructures, including the charge, double charge pair, also the different level of platform for management of the electric vehicle to establish of some kind of nationwide, citywide, the different level of EV battery storage system, including battery to home, battery to building, also battery to microgrid, also to the national grid. So that's also, I think the lesson in China can be helpful for the US.
Has the National Grid or South China Grid put in place any monitoring programs on safety or any rules on the interconnections?
Yes,
for
course.
Batteries?
We have 2 national monitoring systems. One is a national monitoring system for EV vehicles. Another is for charge systems. So these are 2 national systems, and also have a different, for example, the city province level monitoring systems.
Let's see. Okay, I was just looking at, we have one question that came in just now. I'll read that and ask for comments. New York City and countries, latest Norway, recently set deadlines for allowing EV vehicles only within their borders. So the question is whether China is considering such a ban on ICE vehicles in favor of those with 0 emissions. And also any other thoughts related to the new cleaner climate policy approach. Thank you.
Pardon?
So is China considering banning internal combustion engines at some point? Following California's example.
That's very sensitive in China. You know, several months ago, I in one of a meeting, I mentioned that, but that in the media, many people against me. So that's very sensitive for the common customers. It's very difficult to accept that at the moment. But I think in the future, because in China, the EV market is increasing very quickly. So for example, this year will be 100% increase compared to last year. We think the next year maybe another 100% increasing. So anyway, the EV is acceptable at the moment for the common customer. So now the customer is spending very quickly. So this we are, the battery is very difficult to meet the demand of that. In China, we're going to have a TWh production in 5 years. So that means our battery production capacity will increase in 10 times in 5 years, but still cannot meet the demand of the market. So this means the EV will be expanding very quickly. Then that's a very general process to replace of a conventional vehicle. So maybe it's not necessary to issue the policy to ban the traditional vehicle. So this is a very general process. No problem. I think in 10 years or 15 years, maybe 80% of the vehicle will be electric vehicle. So in China, because it's very popular in China now in the automotive market.
Well, I guess it's a fair question for Anna is in Michigan, the notion of banning internal combustion. When would you expect that to be on the table?
We'll see.
We'll see. Okay.
Well, I guess I have to say that I think it's also important to understand that the grid will be decarbonizing, and we need to have the right pace.
Right.
So we don't cause what we call in engineering an undershoot.
Right. Well, certainly the grid and the load, yeah, it's all connected.
Yeah, but we are very active in the area of well, we're very active, and I think we are working really hard all the way from our governor, and we set up recently an office of mobility and electrification, and there are a lot of activities that we're trying to provide incentives. Of course, the automotive manufacturers are, as you know, are moving aggressively now. It's the time where finally the regulators, the aspirational, the climate change, and the regulators and the manufacturers are actually all aligned. So I think we just need to bring along the customers, the market, and I think it will happen because the cost is going down, and because it's so much fun to drive an electric vehicle. You don't actually even have to go gas it up.
Right. Well, obviously for California, one of the real drivers for zero emission vehicles is that over half of our greenhouse gas emissions are from transportation, both direct and indirect. And obviously 80-some% of the criteria pollutants are transportation. So again, it's sort of the heart of many issues in California are transportation, and going to zero emissions is part of really cleaning up, and obviously our air, but at the same time dealing with, the greenhouse gas emissions. And obviously that issue has really come home hard to us this summer from the fires. There's a lot of concern about how to reduce fire hazard and climate change in California. It's pretty visible. It may be theoretical in some people's minds, but it's real here, I'm afraid. So that really moves the transportation sector to the front of many things.
Well said, Bob. I want to say also in the Great Lakes, it is so important for our whole ecosystem and environment.
Yeah. I think actually we are about at the end. I don't know if certainly would be happy if any one of you wants to contribute any additional thoughts. Otherwise, I was going to certainly invite everyone back to our 3rd anniversary event, which will be next year. And we're looking forward to a really vigorous long life process, and certainly have really appreciated the opportunity to work with obviously other states, but particularly work with China, and to be the vehicle for collaboration between at least California and China and continue to grow that relationship. That's always been a key part of Governor Brown's focus. So again, thanks for your help this evening.